So I hit the 15-minute mark on my last video of making a video for the practice 4 problem, so I'm going to finish it by finishing the problem 5. So this problem states at the beginning of the 20th century, Lucy Cournot was studying the genetic basis of yellow coat color in mice. He carried out a number of crosses between 2 yellow mice and obtained what he thought was a 3-to-1 ratio of yellow to gray mice in the progeny. The following table gives Cournot actual results along with the results of a much larger series of crosses carried out by 2 other investigators, Castle and Little. So there's the table and of the numbers, and so it asks us to find the chi-squared value for Cournot, the chi-squared value for Castle and Little, the chi-squared for the test for them both, and then to ask for what our interpretation is. And so I drew out the table as shown out right here, and so I did the chi-squared for Cournot, and so since we're going out of a 3-to-1 ratio for the Mendelian genetics, that's the pattern we are trying to observe here. And so what I did to get the expected values is that I times each total by 3 out of 4 or 0.75, then I times it by 0.14 or 0.25 in order to get the gray. So I times 363 against 0.75 to get 275.25, then I times 0.25 times 363 to get a 90.75. And so these are my expected values. And so basically I plugged the expected value into here, the observed into this place right here, and then the expected down below. And then I did the same thing for the bottom, and then I came out with this equation. And I got a chi-squared value of 1.188. And so I failed to reject the null hypothesis of a 3-to-1 ratio. Then for Castle and Little, I did the same thing to 0.75 times it against 12.35, and I got this for the expected yellow color. And then took 0.25 times it against 12.35, and I got 308.75. And then so I did the chi-squared value. So I plugged all these values in. So plugged this value, the expected, this observed right there, and then this is expected back there, and I did that, and I did the same process for this. And then I got a chi-squared value of a 68.25, so I rejected the null hypothesis of a 3-to-1 ratio because the chi-squared value was really big. And then the chi-squared test for both, basically what I did is I did the same things I did before, took 0.75 times 1598 to get this for the expected yellow, and then I took 0.25 times 1598 in order to get this expected for the gray, and I plug these values in as shown right here. So these two values go over here, and then these two values go in this one. And then I got a chi-squared value of 60.99, which based on the chart, it's rejected the null hypothesis of a 3-to-1 ratio. And so I believe we have evidence to say that we can reject the null hypothesis. And so our best interpretation is that it's an autosomal dominant disease, but it can be a lethal inheritance. If you inherit two dominant genes, for example, if you inherit big A, it could be possible that it's a lethal gene, and that person who inherits that particular genotype won't arrive. And so that's why more of a 2-to-1 ratio is being observed more often. And so that's our best interpretation of it. And so those are the videos for those are the problems for the problem 4 or problem 4 lesson 4. And so I hope you enjoyed it and hope you learned a lot. Thank you so much.